Assalamualaikum. My name is Amri bin Quentin and I'm from class DKA3A. My number metric is 07DKA19F1040. Today, our group will present our case study. The case study our location is Junction 4 of KK Times Square, Kota Kinabalu, Sabah. Introduction. Junction is a place where two or more roads cross or meet, designed to allow traffic users to change between different routes or directions. This can be ensured by proper geometric design and implementing the appropriate traffic control measures. The junction area background for our study site is located at Junction 4 of KK Times Square, Kota Kinabalu, Sabah. This junction can be used to head to Wisma Muis and close to UTC Sabah. This junction can also be used to get to Imago. The objective of our case study is to solve real-based problem regarding road accident for Lake Junction in Kota Kinabalu area. To gain knowledge of issue and a process in engineering technician practice by design the traffic signal phase 2 to reduce the road accident at the junction by using arahan teknik jalan, to signal the geometric and signal setting feature of typical traffic signal, and last, to prepare corrective measures to improve the performance of the traffic signal. The literature review. The problem encountered at our study site at the intersection of 4 KK Times Square, Kota Kinabalu is due to the busy road using many vehicles passing through the intersection. This can lead to accidents if there are drivers who are selfish with driving or don't follow the law of the road, and this causes the car to collide with each other. The driver did not have time to use the brake pedal because he did not have time to dodge. The problem facing at our junction area is poor maintenance. There are some drivers not follow law traffic and roads broken or damaged. The list of factors causing accident at the study area is human factor, no lesson, do not follow road rules, and carelessness of the driver of the car coming out of the junction. Okay, thank you. That's all my presentation.
Next, the technique for traffic management to solve the real problem is: number 1, road users information management, and number 2, instructions and regulation management. The similarities traffic management with the Pen Borneo project is these functions include continuous monitoring and enforcement of traffic management plans by the all works package contractors, provide traffic safety awareness and educate the public and relevant stakeholders on safe traveling along the highway, and to provide continuous awareness through regular safety programs to the traffic management site personnel and workforce. Among the other traffic management initiatives which have been carried out so far are the festive road safety radio message on popular radio channels like Hits FM and road safety campaign, which will be embarked this year, covering all the 3 regions in the state. So these are the conflict point, which we have 3 with its own symbol, which is first diverging, the second merging, and the last one is crossing. these are the 5 methods on how to reduce the traffic conflict for that junction. So firstly we can make a roundabout. Second, we can make a staggered intersection. Third, we can make a grade separate junction, or as known as interchanges. Next, we can prohibiting right turn. The last one is converting one road to one way.
Hi, my name is Isna Imulak Malfais bin Awa. My matrix number is 07DKA19F1022. I will be presenting about the detail on junction geometric and traffic light design. This is the data that have been provided to us to design the two-phase traffic light system in our case study area. From this data, we know that the phase 1 must be at the north and south, and phase 2 must be east and west. Okay, we just proceed to the next slide. Okay, firstly to design the traffic light system, we should find the value of Q, traffic flow. If you look at the previous slide, we already have the value of traffic flow, but in vehicle per hour. Okay, what we have to do now is to convert the value to PCU per hour, or passenger car unit per hour. To do that, we times the equivalent factor of each vehicle. Okay, after that we will get the value, and all the value we add them all and to get the total value of Q. We do the step for each part at north, south, east and west. Okay, we just proceed to the next slide. After we get the value of Q, we should find the value of S, saturated flow. The lane width have been given for phase 1 and phase 2. For phase 1 is 6.5 meter and phase 2 is 7.5 meter. The two of this value is more than 5.5 meter, so we just have to times it with 525 to get the value of S. We just proceed to the next slide. Next, we should find the value of Y, occupancy of the intersection. By using the formula Y equals to Q over S, we already have the value of Q and S from the previous solution. So we just use the formula for each part at north, south, east and west, and we will get the value of Y. And then we add the highest value from each phase. From phase 1, the highest value is 0.17, and from phase 2 is 0.24 to get the value of Y, and we will get 0.41, which is less than 0.85, which is okay. After that, we can find the total lost time. To get the total lost time, we must have this data. This is data that we get to find the total lost time, L. By using the formula L equals to total intergreen time minus amber time for each phase, plus with the lost time for each phase to get the value of total lost time. So we get 16 seconds. Okay, we proceed to the next slide. Okay, next we can find the optimal cycle time. So from the previous solution, we get the total lost time L equals to 16 seconds and intersection occupancy Y equals to 0.41. By using the formula, optimal cycle time equals to 1.5 times L, 16 seconds, plus 5 divided by 1 minus Y, which is 0.41, and we will get 49 seconds, which is less than 120 seconds, and it is practical. Next, we can continue by find the effective green time for each phase by using the formula effective green time Gn equals to CO optimum cycle time minus L total lost time times with the highest Y value for the phase divide by the value of Y. So we will get the value for phase 1 is 14 seconds and value for phase 2 is 19 seconds for the effective green time. Next, we should find the actual green time for each phase. So just using the formula actual green time G equals to effective green time from the previous solution plus with the lost time minus with the ember time, and we will get phase 1 is 14 seconds and phase 2 is 18 seconds. After we get all the data, now we can start design our traffic light timing. So this is what we get from our previous calculation. That's all from me. Thank you very
Okay,
much.
my name is Muhammad Narizan bin Muhammad. My metric number is 07DKA19F1038. So the conclusion is the law of the road is very important to use as road user. Road rules are so beneficial, especially that we can prevent and reduce road accident. Traffic control can also be one of the reasons to avoid accident. One is with the presence of the traffic light, then bicycle passing through the road will always be smooth and not congested, and road user can pass the road safety. Next, talk about recommendation. First, always maintain the road for traffic use. Second, put more warning board in the road. Thirdly, we make a special path for the pedestrian. For example, we create the space for them. And lastly, install bicycle surveillance camera carrying fast bicycle. So that's all from our group. Thank you.